Hi, we have big things to learn today, so let's get to it because I am so excited. Hope you are too. Okay, so here's the deal. So we're going to understand the derivative from a graphical and numerical approach. So meaning when we look at a graph, we know what a derivative means. If we're doing this algebraically in some way or looking at a table, we're going to know what the derivative means. So over here it says complete the table below, finding f prime of x. So what I want you to know is that this over here is f of x. So this is my function. I want to label it that this is f of x. And so some people really don't like this page because you're really estimating a lot of things. And a lot of people are like, no, I don't want to do that. But that's okay. So what I want to do is I'm going to go over to this graph and I'm going to say, you know what? If I made a tangent line, meaning a place where it's touching this curve one place, what do I estimate my slope to be? And this is where you're like, I do not like estimating. I want an actual value. Let go. You can do it. Deep breaths. Make sure your shoulders are away from the rest of your body. Do that anyway, because I feel like this is just a tense time in life. It's okay to not be exact on this. And your answer might not be exactly like mine. This middle column won't be. And some of this on the side will be. Okay, so if I'm estimating here, I'm going to count rise over run. So I'm going to go up 1, 2, 3, 4, right one. I'm going to say my estimation is about 4, meaning rise over run. I think before, actually, I looked at what I put before and I had 5. What this means is I'm going up 4, right 1, and that's about what mine is. Maybe yours is 5, maybe yours is something else, but all of us are going to have a positive value, or should, because I'm going up and to the right. And so if I want to know what my function is doing, because I have a positive slope, my function is increasing. And if I want to write my equation of my tangent line, I need 2 things to write the equation of any line. What are they? I'm not saying peace out. Don't peace out. Stay in the video with me. But what are the 2 things? Hey, slope and a point. That's what I thought too. We have so much in common. So for a slope and a point, so my slope of my tangent line is also known as f prime. And I said f prime of -7 was approximately 4. F of -7 is my point, which if I go over 7 and I go down 1, 2, 3. So my equation of my tangent line is y is equal, or y minus y1. So y minus -3, so y plus 3, is equal to m times x minus x1. Hey, we did it. Okay, let's do another one. So go to -6. I'm going to get a different color because I can. I'm going wild and crazy over here. At -6, you draw this. What do you think about your line? So try to actually do rise or run. Count it out. I don't know, 1, 2, 3, 1, 2? 3 over 2? Yours might be different than mine, it probably is, but both of our function is increasing because our slope of the tangent line is positive. And so if I said f prime of -6, I said that was approximately 3/2. Remember, this is my slope of my tangent line. So if I'm saying y minus y1 is equal to m, this is what mine is going to look like. But both of ours should look like this. F of -6 is 0. So y minus 0, x minus a -6. Go through this and do this for all of the other ones. So estimate the derivative, and then you're going to figure out what is your, is this function increasing or decreasing, and then what is your equation of your line going to be. So take a moment. I'm going to keep doing this, but in Edpuzzle, I'm going to stop you. Okay, keep going. Okay, so check yours with mine. And you can see right now that I went through and I put the slopes, and there's even some of these that I definitely think could be something different that are not necessarily 4 or -5, but there's something close to here. If I have something negative, you should have something negative. If I have something that is 0, you should have 0, positive, positive, because this column, the decreasing, the relative min, increasing, relative max, that should be all the same. Remember from pre-calc or from algebra 2, that a relative max is something that's not necessarily highest point on the graph. It's like the relative highest point. So the relative maximum would be right here. It's like if you're tall in your family, but you're not really all that tall. If everyone's around 5 feet and you're like 5'3", it doesn't mean you're necessarily like a giant or anything, but you're probably tall for your family because you tower over them by a whole 3 inches. Same idea here, relative max. Relative min, so relative to the things around it. This one is actually also an absolute max, but we would talk about that later. But we would even say relative to the points around it, this is a relative max. That's where these are coming from. In this, you should also be looking, so I just wrote down what my point and my slopes were. You can go ahead and fill in the slope formula for the rest of these. So, or not, I'm sorry, not the slope formula. What am I talking about? Point slope form. So y minus y1 is equal to m times x minus x1. I was going to say I wasn't going to do it, but it's really hard not leaving something blank. So y minus y1 is equal to m times x minus x1, y minus y1. So the same idea every time. Oh, my big face is in the way. There we go. Y minus 2 is equal to -5 x minus x1. Okay, we did it. I'm sure I made a mistake in there somewhere, but just because I did it fast, actually I don't think so. But I'll catch it later, or you catch it and let me know. It's really just important that you know to do the equation of any line, you have to find a slope and a point. And the slope is the derivative. The slope of the tangent is the same thing as derivative. Derivative is the same thing as, you got it, slope of the tangent. Okay, so moving right along. The next thing I'm going to do is the next page, which is 53. Yeah. Woo, page 53. 53, when we get to that page, it doesn't quite have enough celebration, so don't worry. It's been celebrated now. So based on what we have observed in the table in the previous graph, what inferences can you make about the value of the derivative f prime and the behavior of the graph? What happened when f prime of x was greater than 0? So my slope of my tangent was greater than 0. F of x is increasing. When the slope was less than 0, so when I had a negative slope, f of x is decreasing. And when f prime of x, the slope of the tangent, was exactly 0, I'm going to say f of x has a possible relative min or max, or relative max. So either one of those is fine. I can write out relative. I guess this is the first time that I've been writing this, so I should write it out. So it can have a possible relative minimum or relative maximum, and min or max is fine, and not write minimum or maximum. You can just write min or max, and I'll know what you're talking about. Okay, so numerically, the value on the derivative at the point can be estimated by finding the slope of the secant line. So again, if you can't come in first place, you know, with the slope of the tangent line only touching once, the next best thing is to come in secant place. Okay, so what we're going to do is we're going to find, if we just have a table, so we're doing this numerically, if we just have a table, what is the closest I can possibly get to finding the derivative? So if I want, let's say at x equals 0, and I want to find the derivative, and think about the derivative is the slope of a tangent, so the slope of like a point like that. It's not my best tangent line. If I found the slope of a line that went through there, so 2 points beside it, it almost looks like the same line because I'm not that great at drawing. That's pretty close. It's a pretty good estimate. So if I want to find the estimation for the derivative we know is the slope of the tangent. To estimate this, I'm going to find the slope of the secant. And I'm going to be thinking about y2 minus y1 over x2 minus x1. And I'm going to use points. So if this is at 0, I'm going to pick a point to the left and a point to the right. I don't care that this is only 1 away on the right, but 3 away on the left. That's okay. For my x values, I just do the best that I can possibly do and do 1 on the right, 1 on the left. And you always have to show your work for this to get full credit. Anytime you're estimating this, like, you have to show the difference quotient. Ooh, coming back from Unit 1 test. Meaning you have to say, like, what's on top, what's on the bottom. So in this one, I would say at 0, I'm just going to say y2. So if you wanted to say f of 1 minus f of negative 3 over 1 minus a negative 3, which is also going to be known as negative 3 minus 2. This would be negative 5 over 4. And so without even seeing the rest of this graph, if I want to know is the function increasing, decreasing, or at a relative max or min, I can see that the slope of the tangent, or in this case the slope of the secant, which I'm estimating to be the slope of the tangent, is negative. And we said if f prime was negative, then f of x is decreasing. And this one's a little weird then. If we're finding the equation of the tangent line to x, there are two things that I need to find the equation of the tangent line. What are they? Slope and a point. My slope is going to be what I just found. So f prime of 0 was approximately negative 5 over 4. Don't choose one of these other points though for your point. You're actually going to go back to that original one. So I would say f of 0 is 1. And then you're going to do y minus y1 is equal to m times x minus x1. So every time you're going back to a slope and a point and finding the equation of that line. I'm going to change colors because I can do that. So for 1, you want to estimate which 2 points are you going to choose? I chose this one and this one. So I'm going to say f of 4 minus f of 0 over 4 minus 0. F of 4 is 0. F of 0 is 1. And I get negative 1/4. Negative 1/4. Negative slope means the function is decreasing. And then you keep going with this. Like, skip through any part of this that you don't think you need, and then come back only as needed when you check your work. So f prime of 1 is going to be approximately negative 1/4. So I know y minus y1 is equal to m. I know that my slope is negative 1/4. And I know my point. I'm going to go up to my actual point. So f of 1, in this case, which is 1, negative 3. So I can substitute in those values. Did it. Oh man, you can barely see that. That's okay. Oh, there we go. Okay, let's do another one. So I'm writing in red. I just did green and now it's red. It's almost Christmas. I love Christmas. I know that's surprising, but I love all sorts of holidays. But Christmas, so great. Okay, so I'm at this point. So I'm picking a point to the left and a point to the right. So I'm going to say f of 6 minus f of 1 over 6 minus 1. Also, I'm well aware that you could do this in your head, but you have to show me what you're actually doing. And so I want to get in the habit of you showing your work so that anybody reading this, it is abundantly clear that you know exactly what you're doing. So negative 7 minus negative 3 over 5, which would be negative 4 over 5. And I've got another negative slope, which means my function is decreasing. I need a slope and a point, so f prime of 4 I know is approximately negative 4 over 5. And I've got my point of f of 4 is 0, because I'm going up here to this one. There it is, this one. F of 4 is 0, so I've got y minus 0, and then I've got x minus 4 over here. I did it. You don't have to simplify anything. You could, but you don't have to because you don't want to mess up doing that part. Let's do one more on this page. So I've got 6, so I'm choosing a point to the left and to the right. F of 10 minus f of 4. So I'd have 2 minus 0 over 6. 2/6 is the same thing as 1/3. Hey, this one's positive. That's exciting. Do you see how I smiled about that? I said positive and then I smiled anyway. So in this one, if I've got 1/3, that means this function is increasing because I have a positive slope. And if you need to like do this and be like, positive slope, yeah, going up to the right, yeah, I'm increasing. You can do that. So f prime of 6 is approximately 1/3. F of 6 is -7. So when you're writing your equation on your line, you should get... And as always, ask me if you have any questions on any of these. But we're going to keep going. I know you were hoping, you're like, do I get to do more calculus today? More calculus. Okay, so a lot of this is just reinforcing what you already know, though. So in this one, it's saying this function g of x is pictured at the right. This is going to be really, really important to label this. Because in this problem, but later you're going to have derivatives and you're going to have original functions and you're going to want it labeled. Okay, so I've got g of x. And so I want to know, where is g prime of x less than 0? So before I even look at this, even though I already labeled it, up at the top it says identify the following characteristics about the graph of g prime. Give a reason for your answer. So in this one, I'm actually going to give the reason before I even look at the graph. I'm going to say g prime of x is less than 0 when g of x. So let's say this in a different way. I'm going to say g prime of x. Instead of g prime, I'm going to say the derivative. Instead of the derivative, I'm going to say slope of the tangent line. So the slope of the tangent line is less than 0. The slope of the tangent line is negative when g of x is, did you say decreasing? We have so much in common. And if you didn't, now you're thinking decreasing because you're listening and you're writing this down. So good job. Okay, so g prime of x is less than 0 when g of x is decreasing. And then I'm going to go over the graph and see when does that happen. And I can see there and there. So I'm going to say on the intervals, and I'm writing intervals so then I can say, I can use parentheses and it doesn't look like I'm writing a point. Because at -4, g of x has a slope of 0, meaning g prime of x is 0 because it's at the relative max. So I can't include that, so I can't use brackets here. So I can say this from -4, because it's an x value, to an x value, to -2. And don't write union, because that means some other things, and it has to be constantly decreasing on that interval. And yeah, just write and save yourself a world of trouble. This would be 1, because this is my x value, to infinity. Because if I keep going to the right, my x value is going to keep going higher and higher and higher. Fun fact, never put a bracket on an infinity anyway, because infinity is not a number. So it could never be included because there's always something beyond it. Okay, the next one, when g prime of x is greater than 0. So do the same thing as last time and write the first, you're going to write the justification. So g prime of x is greater than 0. So I'm giving a reason before I even start. G prime of x, also known as the slope. The slope is greater than 0. The slope is positive. So I'm saying this over and over in my head different ways. When g of x is increasing. And then I'm going to say this occurs on the intervals. And now that you gave this answer, you can use it to help you find this over here. I can see here and here. So that is going to be negative infinity, because I'm going from an x value to an x value the whole way to -4. And from -2 to 1. And that's it. Okay, if we do another one, where is g prime equal to 0? So g prime is equal to 0. And this one is a little bit harder because you're trying to think about like, okay, it's not positive, it's not negative, it's just stop. The slope is 0. When does that happen? And the answer is when g of x has a relative min or max. And I'm going to say this occurs at. This one will not be an interval because it's only x equals 0 for a moment. A little bit before, a little bit after, it's going to be slightly positive and then slightly negative really quickly. So I'm going to say x equals -4 and x equals 1. Okay, so then we get another graph. Oh, at least this one we're talking about something normal. Normal just means perpendicular to the tangent line. It's not used a lot, and a lot of times it will say perpendicular to the tangent line and not even use the notation of normal, but we're going to here. So normal line, this is the line perpendicular to the tangent. And this is at the point of tangency. So what I mean by that is if I'm talking about x equals 1, that's the first one, and the tangent line is right here, perpendicular to that, so running this way is going to be, and going through that point x equals 1, that's what we call the normal line. So this is this graph. It says f of x is over here, and I can see it. And it says draw the tangent line to the graph at x equals 1. Okay, I actually did that already. That's nice. Estimate the value of f prime of 1. So if I'm estimating, I don't know, I go down to right 1, I'm going to say approximately -2. And it's close. Mine isn't even that nice. It's actually like go down to over probably more than that. I just know that this one's going to be -2. So just get close. Find the equation of the tangent line. I had two things. What are they? Oh, it's a slope and a point. So I'm going to say y minus the point that I'm talking about here, f of 1 was 2, sorry, f of 1 is 2. So I'm going to say y minus y1 would be y minus 2 is equal to m, my slope of my tangent line was -2, x minus x1. So that would be my value of 1 because it said x equals 1. If I want the equation of the of the normal line, and right here it says perpendicular to the tangent line, so it gives you that too, at the point of tangency, meaning at this value, 1, 2. Draw this and find the equation of a tangent line. So what I'm going to do is actually, before I even draw this, I'm going to remind you of something from probably Algebra 1. If a line is perpendicular, its slope will be the opposite reciprocal. So if I have a slope right now of -2, and this is like -2 over 1, opposite reciprocal means I flip the fraction and make it positive. Everything else about this is going to stay exactly the same. So this would be y minus 2. But instead of -2, I have 1/2. And what this is saying is if I'm at a point 1, 2, I could go up 1, right 2, up 1, right 2, down 1, left 2. And if I would draw this correctly, this will form a 90-degree angle and be perpendicular. Okay, one more thing. Let's do one more. One more page. One more page. No? No one's joining in. Maybe? Okay, one more. So the same idea, I want you to just go through and practice this. So if you want to pause me, or I'm going to probably make you pause me because on Edpuzzle, but if this is h prime of x, this is the graph of h prime of x. The graph of the derivative is h prime of a function h of x is pictured below. So what this is saying is that this is the graph h prime of x. It's super important that you label this because this derivative is the thing that's pictured. So we need to start thinking about this in a totally different way than we were thinking before. We need to think, okay, this is h prime. This is the slope. Oh my goodness, what does that mean? What I'm going to tell you that means is you have to look at the graph in a new way. So if I want to know where h of x is increasing, I'm going to totally ignore this at first. And I'm going to say h of x is increasing. And then think about the slope. When h of x is increasing when h prime is positive. And I'm going to say this occurs on the interval blah, 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 to blah, blah, blah. I don't know what it is yet, but I'm going to go there. Okay, here's where you have to change your thinking. H of x is increasing. Some people are naturally going to want to say, oh, well, here and here, because this is where h prime is increasing. It's not the same as h of x increasing. So what you need to think about is, okay, I said when h prime of x is greater than 0. That's another thing known as positive, or above 0. This is where h prime of x, anywhere on here, is equal to 0. Anywhere above this line, so all these values, is where h prime of x is positive. Negative is going to be below that line. Think about the function values, so the y values. That's where h prime of x is negative. So I'm going to write in this one, h of x is increasing where h prime is positive, and I'm thinking anything above that x-axis. So in this one, this occurs on the intervals. I'm going to say -2 the entire way to +1, but then I can see at 1, h prime of x is equal to 0. So I can't say it's above 0. It's just exactly 0. And I'm also going to say 3 to infinity. Remember, you're going an x value to an x value, and then here an x value to an x value. Okay, decreasing, do the same business. So decreasing, if you were thinking about this, you do this without even looking in the graph. H of x is decreasing when h prime is less than 0. Anything below 0 is going to be below the x-axis. So I'm going to say h of x, or this occurs on the intervals, and you want to say an x value to an x value. Negative infinity to -2, and 1 to 3. A relative maximum. So this is where h of x has a relative maximum. Remember that h of x has a relative maximum. And this one was kind of hard because so far all we've said is h of x has a relative max when h prime is equal to 0. But that's not quite enough. I need to say even more. So I'm going to say when h prime is not just it's equal to 0, I want to say when h prime is changing from positive to negative. And the reason why, if you think about this, positive to negative would mean for h of x increasing to decreasing. So increasing to decreasing, positive to negative. So let's think. I read from left to right. So where in the graph? I'm going to go here. This would be negative to positive, reading from left to right. Positive to negative. Ooh, that's exciting. So I'm going to say this occurs at x equals 1. And then here is negative to positive again, because I'm reading from left to right. I'm going to do the same thing here in the next one. So relative minimum, h of x has a relative min when h prime of x changes from negative to positive. And I can say this occurs at x equals -2 and x equals -2 and x equals 3. The last two, you just really have to think through. What is the normal line? What is the regular line? So in this one, it says h of -1 is 1/2. So I have a point. What is the equation of a tangent line? I need two things. I need a slope and a point. Remember in all the other ones we've done so far that the slope was h prime of whatever that value is, the x value. If I go up to my graph, h prime of -1 is 5. I know what it is. So even though this doesn't look like all the other ones, we still have a slope, we still have a point. So I can say y minus y1 is equal to m times x minus x1. Same deal on the last one. I've got h of 2 is -3, so I've got a point. This is the equation on the normal line, so I need a slope. The normal line is perpendicular to the tangent. So if I know h prime of 2 is -2, my new slope of my normal line is going to be, slope of my normal line will be the opposite reciprocal, so 1/2. So I've got y minus y1 is equal to m, 1/2, x minus x1. Hey, thanks for bearing with me. I think you're awesome. We'll do more calculus soon. Bye.